Friends, this question from Quiz1 question paper. Consider a 5 puzzle is a sample state shown in the figure. It is represented in a row measure format, row 1 and row 2. For example, 2 0 1. So this is row 1 and this is row 2. Row 1, row 2 measure puzzle, row measure format puzzle. 2 0 1. This is 0 represents the empty space. Yes, empty space. This is a 5 puzzle, that is 5 numbers. 5 numbers, that is 1 2 3 4 5 and 1 empty space, right? 1 empty space. 1 empty space. So total possible states states are 6 factorial. Total possible states are 6 factorial. Starting from the start state. So start state is given. So like this, 1 2 3 and 4 5 and 0 is the empty space. Identify the state that can be reached in exactly 3 moves without duplicating the state along the path. So no duplicating states, they don't allow duplicates. So which options are the correct? This is the starting state, yes. Okay, from starting state to next this state we want to reach. This is the goal state. So that is goal state is 1 0 2 4 5 3. We can move horizontally, we can move up, down, left or right. Okay, no diagonally is not possible. We cannot move 3 here, it's not possible. So 1 is in the correct position. Okay, next move 2 here. So there is no empty space, so move 3 here. So for the first move, so 1 2 is here and this is 0 0 3 5 and 4. No duplicate states are allowed. So very important, without duplicating any state. Remember this one also. Okay, next for the second move, 1 is in the correct position, so 0. So move 2. So because in the goal state 2 is in this position, so for this, so 1 2 move 2 here. This is 0 3 5 4. We reached this state, but the number of moves are only 1 and 2, only 2 moves. So this is because of that, this is the not answer. This is the not correct answer. The second option 1 2 3 and the goal state is, for the second option the goal state is, so 1 3 0 4 2 and 5. So 1 is in the correct position, 4 is also in the correct position in the start state. These 4 numbers are not correct. Please move 5 to this place. That is 1 4 correct place and 2 in here and 3 is here. 1 2 correct place, don't move these 2 and move 5. First move, for the first move right side 5. This position is empty for the first move. For the second move, in the goal state 5 is also in the correct place, right? 1 4 5 are in correct place. So 1 4 5 are in correct place. So don't move these 3, move 2 and 3. For the second move, 1, 4, 5 are in correct places. So this is the empty space. So move 2 down. For the second move 2 down, 2 here and 3 is here. So 2 is also in the goal state correct place, right? 2 is also in the correct place. So all these 4 are in correct place in goal state. This is the goal state. This is the starting state given in the question. So for the third move, they are asking exactly 3 moves. Exactly 3 moves. So for the third move, so 1 is in the correct position, don't move. 4 is in the correct position, don't move. 2 is in the correct position and 5 is also in the correct position. 3 is here and the empty space is here only. Move 3 left. So 3 here, empty space is here. We reached the goal state. For the option B, they are given 1, 3, 0, 4, 2, 5. So 0 means empty space. 1, 3, 0, 4, 2, 5. So this option is correct. We reached exactly in 3 moves. This option is correct. For the next option C, 1, 2, 3, 4, 5, 0. For the option C. This is for option C. This is for option B. This is for option A. Okay. This is the start state. And the goal state is, we want to reach this state. Goal state 0 to 3, that is first space is empty. 0 to 3, 1, 4 and 5. So for the first move, so check which states are exactly in the correct position in the goal state and the start state. 2 and 3 are in the correct position. This space is here, right corner. So move 5 here. For the first move, so 2, 3 in correct positions. Move 5 here, 5 here, 1 and 4 and empty space is here. In the goal state, 5 is also in the correct position, right? So don't move 2, 3 and 5. Move 1 and 4 only. Okay. So for the second move, 2, 3, 5 are the correct places. In the goal state, so 1 is here, 4 is here. So we want 1 down. So there is no empty space. 1 we cannot move here, diagonally we cannot move. So move 4 here. Move 4 right. Move 4 right. So 4 here, 1 is in the same position. Okay, for this second move. So from this goal state, 4 is also in the correct place, right? 1, 2, 3, 5 all are in the correct places. So for the third move, so we reach here. For the third move, only 1 empty space. Move 1 down. So move down, 1 down. So 1D means move 1 down. So we reach, move 1, empty space is here, 1 is here. So 1 is also in the correct place. We reach the goal state. So option B is the correct answer. Option D, let us check the fourth option also. And the starting state is here. Start state is 1, 2, 3, 4, 5, 0. Starting state, yes. And the goal state is in the option given 2, 0, 1. That is 2 empty space 1 and 3, 5, 4. 3, 5, 4. This is the goal state. Correct place, right? 5 here, here in both the places correct place. rest all are in the wrong position. So move 5 here, or if we move 3 down, only there are two options, move 3 down or 5 here. So 1 2 3 4 0 5. So no one in the correct position, so move all. For the second move, 2 4 5 and 3 1. For the third move, 1 2 here, so move 1 4 2 3 5. We cannot reach the goal state using this path 1, that is path A. We tried path A, other also possible, right? So here empty space 3 2 1 4 for the first move. For the second move, if we move 4 here, no duplicate states are allowed. So 1 2 3 5 4. For the third move, move 1 down, 1 4 5 2 3. So we did not reach the goal state B. So we have two chances here. Right? If we move 5 here, 3 here, so two chances are completed here, or 2 here also, right? From this, for the second move, 1 2 3 4 5. For the third move, also it's not possible. If we move 3 here or 1 here, it's not possible to reach the goal state. This is also not possible. This is not the correct answer. We did not reach the goal state in exactly 3 moves. It is true about the 5 puzzle state space, which is reachable from 1 2 3 4 5 0 state. That is initial state. 1 2 3 4 5 0 is empty space. So every move is irreversible. This is option is correct because there is a one empty space. If we come 3 down or 5 right, we will go back, right? We can reach the previous state. We will go back. If we go back to left, if we go back to up, we reach the previous state. The move is reversible, right? Means reach previous state. That means this is an undirected graph. Undirected graph means A to B there is no direction. If we reach A to B and B to A, that is loop also possible. In the same way, every graph is reversible, means we can reach the previous state and it is an undirected graph. This option is correct. And there is a path from every state to every other state. Yes, the total 6 factorial total number of states, and half of these 6 factorial states are reachable states, and these are all reachable states in one connected component. component, and it is undirected graph, so every state is reached to every other state. That means there is a path between each state to every other reachable state. Okay friends, remember one connected component only. There is two connected components in this question. One connected component, every state is reachable state is reached to every other state, possible to reach the every other state in a single connected component. One means single connected component. Because the all moves are reversible, that is all states are connected in a, so there are so many states connected in a loop forward and backward in the clockwise or anti-clockwise direction. That is, we can reach every state, reachable state. So option B is wrong, is not reversible is wrong, because we can reach the previous state. We go back in a sliding puzzle, we can reach the previous state. If every state has at most 3 neighbors. For option D, at most means not greater than 3 neighbors. That means less than or equal to 3 neighbors. So that is neighbors are less than or equals to 3. So that is neighbors are equals to 3 or less than 3. So in this sliding puzzle, one, 2, 3, 4, 5, 0 is the empty space. How many cells are there? 1, 2, 3, 4, 5, 6. 6 cells, total 6 cells. That is 2 cross 3 grid. 2 cross 3 grid puzzle. That is sliding puzzle. So if the empty space is at the edges, so here if the empty space is at the corner, right, it has two how many moves? Neighbors means how many moves or how many options to move. Number of moves. Neighbors means number of moves. So if the empty space is at corner, so 5 can move right, 3 can move down. That is 2 moves, right? 2 moves are possible. If the empty space is at middle position, for example 1, column 2, column 3, so row 1, row 2. So if the empty position is at the middle column here, that is 1, 2, 3, 4, 5. How many options it can move? So how many number of moves are possible? Here 2 moves are possible at the corner position. Very, very important. Okay, we can move to right, 2 right and 1 left and 4 up, right? So left, right, up. 3 options are possible. That is 4 up, that is move 4 to up, 2 to right and 1 to left, right? 1 to left. 3 moves are possible. How many number of moves here? 3 moves. That is maximum number of neighbors is 3, right? Number of neighbors are number of moves. That is maximum number of neighbors are 3. But so answer for this question is less than or equal to 3. That is the neighbors are less than or equal to 3. 2 are also possible, right? If it is at the corner positions, corner edges, 2 neighbors are possible. If it is at the middle column, 3 neighbors are possible. So answer for this question is every state has at most is this one is important, at most 3 neighbors. This option is also correct. At most means less than or equal to 3. Friends, thank you for watching.